So we're looking at composite functions containing the trig function and its inverse. So the sine of arcsine of x is equal to x, or this could be written sine of inverse sine of x is equal to x, or you could have inverse sine of x is equal to x. So this is based on that property of functions and their inverses. F of f inverse of x equals x, or f inverse of f of x equals x. So that's going to be true for the trig functions, provided that we stay within our limited domain and range. So, for example, let's say we want to evaluate the cosine of the inverse cosine of negative 1/2. And so we can always evaluate these from the inside out. So the angle whose cosine is negative 1/2 is going to be a pi over 3 angle, but since it's negative, it'll be in quadrant 2. So this is the angle 2 pi over 3. And then we're evaluating cosine of 2 pi over 3, and that's going to be equal to negative 1/2. If I have, though, something like the cosine of, let me write it this way. Let me find the inverse cosine of the cosine of 4 pi over 3. Well, 4 pi over 3 is outside of the limited domain of 0 to pi. So I cannot just say that this is equal to 4 pi over 3. I have to evaluate from the inside out. So I know cosine of 4 pi over 3 is the pi over 3 angle in quadrant 3. So that'll give me cosine, it's negative 1/2. And the angle whose cosine is negative 1/2 is going to be equal to 2 pi over 3. Okay, so we can evaluate these composites from the inside out. If we are within the limited domain and range, then we can simply use this property of inverse functions. But like I said, you have to be within the limited domain and range in order for that to work. We can also evaluate other composites involving inverse relations. And by the way, your calculator has an inverse trig button. So for the inverse sine, cosine, and tangent, it's typically the second function above the sine, cosine, tangent on your calculator. So if you put in your calculator second tan 1, in degree mode, it's going to tell you 45 degrees. What is the angle whose tangent is 1? Well, that's 45 degrees. If you did second tan negative 1, it's going to give you negative 45 degrees. Okay, so that second tan, just so you know, second tan is going to be arctan. That's just on the calculator. Okay, but we can also evaluate other composite functions. So let's say, for example, we're asked to find the secant of arcsine 4 over 5. So in this case, this is typical problem. Let's say you're told the sine of theta is equal to 4 over 5. Find the secant of theta. So you don't really need to know theta, you just need to draw a triangle. And when we're dealing with arcsine, we want to make sure we draw that triangle in the right place. So since this ratio is positive, we'll draw our triangle here in quadrant 1. And this is saying the opposite over the hypotenuse is 4 over 5, so 4 over 5. To find the secant, which is the hypotenuse over the adjacent, we're going to need this third side. That's going to be positive 3. And so the secant, the answer to this question, would be 5/3. Hypotenuse over adjacent. If we're given a negative number, let's say we want to find the cosecant of the angle whose cosine is 8 over 17. Let's make it negative 8 over 17. So the fact that my arc cosine is negative means I'm going to draw my triangle in quadrant 2. And so I know my adjacent over my hypotenuse is 8 over 17. It's going to be negative 8. The hypotenuse would always be positive. And then we have to find the third side. The third side here would be 15. The cosecant is the hypotenuse over the opposite side. So this is my theta here. And so the hypotenuse over the opposite side is going to be 17 over 15. So these problems are very similar to saying this is my sine or my cosine of has this ratio. What are the other 5 ratios? Except it's only asking for one ratio. And now an extension of a problem like this for calculus might be, what is the sine of arctan x? So we're not given a number, we're just given a variable. And so we can still draw a triangle that represents that. I'm just going to draw it in quadrant 1. And this is saying my opposite over my adjacent side is equal to x. Well, I can write that as x over 1. And to find the sine, I'll need my hypotenuse. So the hypotenuse, r squared, is equal to 1 squared plus x squared. So r is going to be equal to the square root of 1 plus x squared. You could write it as x squared plus 1. And so the sine then, which is opposite over hypotenuse, is going to be equal to x over the square root of 1 plus x squared. And that's another type of problem that we can evaluate, and that's some algebra for calculus. Another quick example like that. Let's say I find the cotan of the arctan of 1 over x. So I'll draw my triangle. Here's my theta. My tangent is 1 over x. Well, to find the cotangent, the tangent is opposite over adjacent. The cotangent is just adjacent over opposite. So it's just going to be the reciprocal of this term here. It's just going to be x. X over 1 or x. And that is our study of inverse functions.